This is Mr. Beck Does Your Homework, Homework 14, questions 8 and 9. Questions 8 is a little bit tricky. It says, a satellite is in a circular orbit 21,000 kilometers above Earth's surface. So what that means is that I've got Earth, I've got the radius of Earth, and then I've got also this distance to the satellite that's orbiting around the Earth. Okay? So this is my, I'll call it my height, this is my R, my radius of the Earth. Find the speed of the satellite. The radius of the Earth is this, and the acceleration of gravity at the satellite's altitude is this. The acceleration of gravity is that. That's interesting. So why does the satellite go around the Earth? Is because it's got a force on it, and that force is the universal gravitational force pulling it towards the center of the Earth. Well, I can also think that that force is accelerating the satellite, and that force of gravity accelerates the satellite such that the acceleration of gravity is going to be a centripetal acceleration. So I know that my acceleration is going to be v squared over r. So that's kind of neat, where we didn't really cover this in class, but if you take a look at it now, you'll see that the acceleration is centripetal, is v squared over r. So they give me what this acceleration is 0.532655. So all I'm left with is, let me find r. So let me solve this for v squared, so let me multiply by r. So my acceleration times r square root is going to be the speed of the satellite. My acceleration is 0.532655 meters per second squared. And my radius here is going to be the radius of the Earth, which is 6.37 times 10 to the 6th, 6.37 times 10 to the 6th, plus how high above the surface of the Earth, which is 21,000 kilometers. So that's 21,000 meters. So that's 21,000 kilometers. So if I take this, and that's what, 2.1 times 10 to the 7th, add those together, and I'm going to get my radius. So now my velocity is going to be the square root of that acceleration times that radius. So that's going to give me the speed of the satellite up at that height. Oh, but careful, it says answer in units of kilometers per second. This will give you meters per second. So how do I get kilometers per second out of that? Well, if it goes this many meters, it's going to go 1/1000th as many kilometers. So if you divide by 1,000, that's going to give you kilometers per second. Now it says find the time it takes to complete one orbit around the Earth. Well, how far is one orbit around the Earth? Well, that's the circumference of a circle. So that's going to be 2 pi r is my distance. I want my time. Well, I know that my velocity is my distance over my time. This is my distance. This is going to be my velocity. So my time is going to be my distance of 2 pi r, r being this whole big number, divided by my velocity. And that's going to give me the amount of time it takes to go around in seconds. Make sure you use the meters per second when you use your velocity. So this meters per second is what you're going to use for your velocity there.